Hello everyone, in this lesson we're going to be talking about the moon and its eclipses. So just so you have an idea of the relative size of the moon, it's about the same size as North America. Now, similar to the Earth, the moon has a rotation as well as a revolution, but different to the Earth is that it spins on the axis in the same amount of time that it takes to orbit the Earth. So what effectively that means is that we only ever see one side of the moon. The back side of the moon, well, from the Earth perspective, is never seen by people on Earth. So the revolution and rotation of the Earth-Moon takes around 29 days. On this slide, I want to explain the phases of the moon. So phases are new moon, waning crescent, third quarter, waning gibbous, full, waxing gibbous, and first quarter. These phases are caused by the sunlight reflecting off the surface of the moon. So let's take a look at new moon. If the sunlight is coming from over here and the moon is right here, then sunlight is only going to be reaching 1/2 of the moon, and it will not be reflecting any light on this side of the moon. So this side of the moon is reflecting sunlight, and this side of the moon is not at all. So from the perspective of the Earth, what we see is this, the new moon, the dark moon. I say dark moon just because it visually is not as illuminated as sort of a full moon. In contrast, we look at the full moon. The side that we see, the side that is facing the Earth, is completely illuminated by sunlight, and so we see a full moon. It is completely illuminated. And as we move through the phases of the moon, different sections of the moon are being illuminated by sunlight. So, for example, if you look at first quarter or third quarter, this side of the moon is still being illuminated. Notice it's the same side being illuminated every single time, but the side of the moon that we see from Earth appears as if it's half illuminated. So the phases of the moon is all sort of perspective from the Earth. Now, new moons and full moons are of particular importance because these are the stages in which we will see eclipses. So, for example, this new moon is when the moon is between the sun and the Earth, and so we will see a lunar eclipse, or we could see a lunar eclipse when the moon is a new moon. A full moon is when the Earth is between the moon and the sun, and so we can see solar eclipses when this occurs. So we have two types of eclipses. We have solar and lunar eclipses, and how we figure out which is basically based on the orientation of, or the alignment of the sun, the Earth, and the moon. A lunar eclipse occurs when the moon passes through the Earth's shadow. So that means the Earth is between the sun and the moon. This will only happen during a full moon. I'm a bit worried I used the wrong sort of terms earlier in the slides, but just know that a lunar eclipse occurs with a full moon and will occur at night. So lunar means moon, occurs at night. That's one way you can try and remember it. If you take a look at this diagram, it is showing us a lunar eclipse. As you can see, we have the sun, the Earth, and the moon. And the Earth is between the sun and the moon. Just like you on a summer's day, the Earth will create a shadow. So you have shadows, the Earth will have shadows. And so this right here is the Earth's shadow. We have the penumbra and the umbra. Now, I want you to pause the video and go check out the video on lunar eclipses that I posted below. Okay, hopefully you paused the video. Now we're going to move on to solar eclipses. A solar eclipse is where the moon is between the sun and the earth and actually causes or casts a shadow on the earth. This will only occur during a new moon. Solar eclipses will occur during the daytime. So solar means sun, it occurs during the day, whereas lunar means moon, and lunar eclipses occur at night. Here again is our diagram, this time of a solar eclipse. As you can see, our moon is between the earth and the sun, which means that it can create a shadow on the earth. Similarly, the moon will have a penumbra and an umbra. There is something called the total eclipse of the sun or total solar eclipse, and that will only be visible at certain parts of the world depending on sort of various factors. So you may see a partial solar eclipse if you are in a certain city, but if you travel somewhere else in the world, you may see a total solar eclipse, and it just depends on whether you are in the penumbra or the umbra of this solar eclipse. Now go pause the video and watch the videos that I've attached below on solar eclipses. Okay, hopefully you pause the video. Here is one final summary diagram. We have the sun on the right, we have the earth, and we have two options. Here is the moon, a new moon, causing a solar eclipse, or we have a full moon over here causing a lunar eclipse. So where the moon is determines whether it would be a solar or a lunar eclipse. Now you might ask, if the moon rotates around the earth and it takes about 29 days, why don't we have a lunar and solar eclipse every month? Well, I want you to, once this video is done, go watch the video that is linked below, because that explains exactly why we only see lunar or solar eclipses every now and then. So that's it for the lesson. Let me know if you have any questions, and good luck!